currently busy with our trigonometric graphs or functions. And the graphs, you know from grade 10, are the sine graph we looked at in the previous lesson. Sine, the tan graph, and the cos graph. You have to know off by heart. In the sine graph, 1, 2, 3, 4, 5 points. In the tan graph, 1, 2, 3, 4, 5, 6, 7 points and 2 asymptotes. In the cos graph, 1, 2, 3, 4, 5 points. There are different techniques, but this is the one that doesn't fail. If you always go back to your mother graphs and then just apply the transformation, you cannot go wrong. There are things available on your calculator, but then you've got to know to look at the period and the intervals and all the stuff which kids don't do, and then the method fails. So if I asked you in grade 10 to do these transformations, this is old news. We spoke about them yesterday. When there's something in the front of that sin, or tan or cos, the graphs, what is going to change? Amplitude. The amplitude, if it has an amplitude. Because the amplitude here doesn't exist. Right? There is no amplitude, because amplitude is the maximum that it can go to. The maximum that it derives or derails from, resting point. Now, resting point in the tan graph goes until forever and goes until negative forever, so it doesn't have a maximum and a minimum. So for the sin graph, the maximum was 1. Now it's going to be 2. So what you have to do every time you sketch it is tell yourself, what are you going to have to do with this sketch? You're going to take the sin graph and do what to it? Times all the y values. Times with 2. From where? From the mother graph. So now if the mother graph's y value was 0, it's still going to be 0. If the y value was 1, it's now going to be 2. If the y value was 0, it stays 0 at 180. If the y value at 270 was negative 1, it's now negative 2. See, I've got a little bit less space here than I want. And then at 360, the y value was 0. But hear me all the time saying the y value is times with 2. The y value is times with 2. So 0 times 2 stays 0. So that your graph did what? It stretched vertically. Now in grade 10, all of the transformations were vertically. They were either stretched or they shrank. Or they moved up and moved down, and this is what the second example is from last year. You go to your mother graph of tan, where you know the values of these, and then you take each and every one of them and say, what must you go and do? Every y value, I'm so proud of you, every y value has to be. So what about the x? It stays where it was. So for the x value of 0, the y value was 0. And what would you do with your y value? Plus it with 1. So 0 for y plus with 1 is now at 1. For the next one, at 45, you know that the y value was 1. But add 1 to that y value, and the value is 2. And then you can sketch your graph. Those 2 pieces are enough to sketch the graph and go closer and closer to the asymptote. Next point, my third point, 4th, 5th, 6th, 7th, etc. And you can carry on. Sometimes I let you draw a little less, more to the left, whatever, and you just follow the cue. For these examples, I just kept to 0 to 360. It will change every time, and you've got to adhere to where I want to block you off. So in the next step, it was 135 at negative 1. The negative 1 on the y is added by 1, so you get to 0. Add 1. Add 1, you get to 1. Take the next one, add 225. Add 1 and add 1, and you get to 2. So what's happening to this graph? It's shifting upwards. So if I say plus, it goes up. If I say minus, it goes down. If we had times 2 there, it's stretched. If we said times a half, it shrunk. Okay. So now I'm just going to complete the sum. That looks like a straight line. Make sure it's not a straight line when you sketch it. That it goes upwards from that point and downwards, and actually makes a little kink there. Alright, which we call a point of inflection later on in your life. That is where it inflects. It becomes a different shape. Concavity. That's still stuff for in the future. Then the last bit. So do you see me going with all 7 points? I'm just saying add y with 1, add y with 1, add y with 1. So this y that was -1 is now at 0. There by 2, 3, 1, 5. At 0. At 360 it was at 0, now it's at 1. And how do I sketch it? Still the same thing. It has to curve downwards and go closer to the asymptote. And if I had asked you to draw it longer, you would have gone upwards again, and the next asymptote would have been at 90 further, which would have been 450, etc., up to infinity. And this was a good grade 10 question. Just move your graph up. Could we have both of them in one? Yes, we did that. That you times the y with 2 and you add. Then you just take step by step, point by point, and do exactly that. All good. What's the stuff I can ask you? Amplitude would be the better question here. And saying that amplitude is now 2. Period? 360. Never changed in grade 10. It's going to do it now. Never changed in grade 10. The period for the sin graph was 360, for tan was 180. It's still 180. In between the barriers 90 and 270, it still stays 180 units. No amplitude, because it's 10. Right, let's get to the grade 11 work. Now there are different transformations. Now we're looking at horizontal transformations. So the vertical ones was stretch up and down, move up and down. Where are the transformations for horizontal? Look at it. It's next to the x. The x-axis, the horizontal axis. Something's going to happen to your degrees, your angles. Something's going to happen to them. This was all about changing the y. Times the y or add the y or whatever was in my sum. For these, it's all going to be about something changing with the x value. Can you identify that something's happening with the x over here?
Yes.
And in the sum?
Yes.
That there's something happening with the x there?
Yes.
If this was plus 1, was it something happening with the x?
No.
Nope. Unless it was in a bracket, then it was all together with the x. This is something to do with your y value, like always. Right. Now here is the phenomenon. Not something we thought out, but this is going to happen. It's the first time you're going to hear about it, because you're going to hear about this in parabolas and hyperbolas, in exponential, in all your graphs. That whenever there is a horizontal change, it's always backwards. I always speak about boys and girls. Now, boys, what you see is what you get. If we say times with 2, we times with 2. If we say plus with 1, it's up. Minus with 1, it's down. Look at these girls. That's always so interesting. You never know what you have in there. This x, tell me what your thoughts are. What's going to happen with this x? Plus 30. What are you going to do?
Add 30. So
You're
shifting
not
backwards.
going to add 30. You're going to minus 30. Typical girl. She says, maybe I'd like to go to a movie, but she actually says, no, I'm not. When she says, oh, I like a lot of hamburgers, she's saying, no, I don't. If she says, no, I don't like a kiss, she actually does. All right, so it's always backwards. That's the way I'm going to teach it to you about the boys and girls, right? Vertical transformations are always going to be exactly what they do. Times with 2, so you time the y with 2. Plus with 1, so you plus the y with 2. Tell me, what are you going to do with your x here? You're not going to plus it with 30, you're going to minus it with 30. So it's going to go 30 degrees left. That's minusing, right? But you think it must be plus. But I'm telling you now, these girls, interesting. So now how do I do that? Because once you've got this idea, you've got it for life. So you still go back to your mother graph. This time I'm asking you for cos. In the cos graph, what must you do with cos? We just said every x must move 30 to the left. So we go to our mother graph. So that one was at x, that was 0. Now it has to be at negative 30. There's my first point. Second point was at 90. It must move left to 60. The third point, you see me saying 1, 2, 3, 4, 5 that you know, and every single one of them must move. So the next one was at 180. Where was it at 180? At -1, right? So here it was at 180 and -1, but now it must move 1 to the left at 150. You see the whole graph is shifting to the left. It's just this backward thing. And it's not something we thought out, it's actually how it works if you go and do it on a calculator. You would have seen it in your investigation. Yeah. Right. So the next one was at 270, the x was 270, now the x is going to be 240. The next one was at 360, now it's going to be at 330. Now be careful. This sum said, sketch it for me from 0 to 360. So I can't stop there. I've got to go on. And this is now where it comes in that you must know the shape of your cos. Shape of your cos. Where's this cos going? Through there, not at 1, where it usually was. It's through there now. And making ready to go back down again. And here, go back down again. But then you must stop at 360. And you must stop at 0, because that's what I asked you to do. I can let you start anywhere I like. It might have been good to say, okay, let's start at -30, then we're nice. Let's stop at 330, then we would have been finished. You just follow the lead. There are some technical stuff that sometimes that they do, which is, what will be the answer here for that y value? And it's not brain surgery, guys. All you need to do is go to your graph, which is cos x plus 30. What is the x value here? 360, right? So what is over here? 390. Put it in your calculator, please. So cos 390. 0.86. So shall we say 0.9? Rounding it off. Because sometimes they will say show the end points. So I want to know what those specific values are. Because I don't know what that point there is. How will I find out? Well, if you think about it, it should be, according to symmetry, 0.9, but let's check it out. What must you put into your original function? X is now 0. So you're going to work out cos 30, which is 0.86, because it's symmetrical, right? It's always going to be symmetrical around all those points. And there it is, your first grade 11 graph with a horizontal transformation. This horizontal transformation is shifting left and right. So the girls, the x's, go left and right, but it's always backwards. If it says plus 30, you would think it's plus 30 that way. Nuh-uh, it's the other way. And then you take all of your points and just do exactly that. You follow. If you've got this, you just take every single point and shift every x 30 to the left. And you put it in there as an x. Right, so tell me, you're very clever now. Amplitude, did it change? No, the amplitude is still 1. And where do we find the amplitude again? It's still that number there. There's a 1 there. The amplitude is still, let's write it out. But the period, did that change? Also not. It's like I picked up that purple one and I shifted it a little bit to the left. It doesn't look like that because it's a much smaller scale and a much bigger scale, but with me, we never did anything like that. Now we're going to do that. Alright, so tell me, if I ask for sin, then obviously I get to myself quickly to the mother graph. And then I say those 5 points, you see I don't even say everything there, I'm just getting myself together. I know this is 91, 180, 0, etc., etc. Okay? So what are we going to do with our x? Oh, you're so clever. Because it's a girl. Remember, interesting girls. Look, every x must now be divided by 2. So of what? The mother graph. The be all and end all of all the graphs is you must know your mother graph. So for the first point, the x value was 0. So divided by 2. So it's still there. The second one was at 90. So it's now at
45.
So this is at 45 and 1. 45 and 1. The next one was at 180. So take the 180 and divide it by 2. So this is now not 180 anymore, it's 90. Are you following?
Yes.
So we got the next x was at 270. Divided by 2 is 135. So what happens there at 135? The answer is negative 1. Can you see the pattern yet? What will be the next one without looking at the mother graph?
180.
See it? Because there goes my graph. It's just a little bit thinner now because it's shrank horizontally. So now let's finish it up because you cannot just give me that one sine curve. I asked you to go all the way up to 270, not 360 by the way. So I still need to go up here. Where will this one be? Now follow the pattern. So this will be at 1, and then this one will be back at 0. It would have been negative and negative, but you're not allowed to draw it here because I said, stop there. So it's only going to go upwards. You see the shape? Oh, that's a little bit too wayward. Okay. Let's keep our shapes nice. This one would have gone down. You don't draw it there. On that side, because I still need to go to negative 90 in this one. Negative 1 at 45, negative 45, and negative 90. And again, to make the shape as good as I possibly can. You know, guys, it's not art class, but at least it has to have a nice, smooth curve. Period.
360.
What do you do with all your x's? Divide by 2. So the period that was 360 is also divided by 2, which gives you 180. So after a while, I'm going to ask you, don't sketch it, just tell me what's the period. So you should know. Period of sin is always 360. But in this case, I'm going to take all the x's and divide it by 2, so it's going to be 180. Do you see it coming? You know nothing's changing there. Not the period, not the amplitude. The amplitude only changes there. Also, amplitude didn't change it. Could I have made this 2 times? Then the sum would be exactly like it is, but that would be at 2, negative 2, so it would have stretched as well as horizontal. So you can have a vertical and a horizontal, or 2 horizontal things happening in your graph. What didn't change? The amplitude is still 1, and it could have changed. No problem. Are you with me on this new track? Okay.